EVN routing with BGP. In this video, I'm going to show you how you can configure BGP for routing in EVN environment. It's so similar with the configuration of BGP in the VRF Lite environment. But also here we have another difference. The difference is that here we have two VRF and also one global network. The global networks means the physical routing, the physical network or the real network. You know that by default we are using global network, and after we are configuring the VRFs, all of the interfaces that are not reside in every VRF, in one VRF, are in the global network or global VRF. In EVN environment, we have two type of VRFs or VNETs. One type of VNETs is VRF VNETs, for example, VRF A, VRF B, and the other type of VNET is global network. Let me to show you how we can configure the BGP in the VRF and global VNETs. It's so easy. R1, first we should configure R1. We have the host name as R1, VRF definition A, same command as the previous video. VNet tag is 2 for the VRF A, and address family IPv4 unicast now is enabled for this VRF. Again, VRF definition B, VNet tag 3, address family IPv4 unicast now is enabled for this VRF. But we don't need to the VRF definition C with VNet tag 4. Because of that, I'm removing this configuration. Next, interface ETH00 is a member of VRF forwarding A with the IP address of 10.101.255.255.255.0 and no shutdown. That's it. Then interface ETH01. This is the interface of VRF forwarding B or VRF B, and the IP address of this interface is 10.201.255.255.255.0 with no shutdown. Again, interface ETH02. Here now, as you can see, this is not a interface of every VRF. This is the global interface or global, for example, VNet. Because of that, I'm going to remove VRF forwarding C on this interface, and also we should assign one IP address to this interface 10.3.0.1 with the mask of 255.255.255.0 with no shutdown. And then interface ETH03, this is the VNet trunk, the IP address is 10.121/24. Let's go to Rotor 2. In Rotor 2 again, the host name is Rotor 2. The VRF definition A and B is are valid, and VNet tag is 2 for the VRF definition A, and VNet tag is 3 for the VRF definition B, and address family IPv4 unicast is enabled for both VRFs. Then we should remove the VRF definition C. Here we have only two VRF. Interface ETH00 is a member of VRF A, and interface ETH01 is a member of VRF B. Also, the IP address of the ETH00 is 10.4.0.2, as you can see in the picture, and the IP address of the VRF B is 10.5.0.2. And you know that, for example, in the ETH03 or ETH02, we don't need the VRF forwarding C. The IP address of this interface is 10.6.0.2/24, and the interface ETH03's IP address is 10.1.2.2. That's it. And after that, the VPC1, this VPC's IP address is 10.1.0.10/24 with the gateway of 10.1.0.1. The IP address of the VPC2, this VPC, is 10.2.0.10 with the gateway of the 10.2.0.1. The IP address of the VPC3 is 10.3.0.10 with the gateway of 10.3.0.1. After that, the VPC4's IP address is 10.4.0.10. Okay, 10.4.0.10 with the gateway of 10.4.0.2. The IP address of the VPC5 is 10.5.0.10 with the gateway of the 10.5.0.2. And finally, the IP address of the VPC6 is 10.6.0.10 with the gateway of 10.6.0.2. That's it. This is the initial configuration of the VRF and also global network. After that, we don't need the, for example, OSPF configuration. Now, first, we should copy the configuration of R1 into the R1 CLI, copy. Then in R1, I'm going to copy this configuration. And after that, we can configure the R2, the next router. Copy the configuration in the R2. And after that, we should configure the, for example, VPC1 to VPC6. And then we can configure BGP. Don't forget here, we have one global network and 2 VRF. This means that for the global network, you can configure normal BGP. You know that you can configure easily the BGP with the neighbor IP remote AS, and after that advertising the network to the neighbor. But if you have VRF, you should use the address family IPv for unicast for the VRF again, as you learn in the BGP. Let me to show you after configuring the VPCs. This is the VPC4 and then VPC5. Copy the VPC5 here, VPC5's configuration, and finally VPC6. Before configuring the BGP, it's good to check the routing table of R1. For example, in R1, we have 3 routing tables. The first is the global routing table, show IP route, 2 connected networks, okay? 1 over ETH02 and 1 over the ETH03. Very good. Show IP route VRFA. Again, we have 2 connected networks, 1 over the ETH00 and 1 over the driven interface of 10.1.2.0. You know that the ETH03.2 is the driven interface of my config VNet trunk, okay? And then, for example, in R1, show IP route VRFC can show us, VRFB can show us that we have 2 connected network in VRFB. And then we can go to the router 2 here, show IP route. In show IP route, you can see 2 connected networks. Show IP route VRFB can show us 2 again connected networks, and finally show IP route VRFB can show us 2 other connected networks. Very good. Let me to configure the BGP for this scenario. We have 3 types of networks, or 2 types of networks with 3 networks. One type is global network and 2 type is for example, VRF network. Rotor BGP. This is a configuration of BGP router config. Rotor BGP AS number. Assume that here we have, for example, if you can configure eBGP or iBGP, it's not different for us. Rotor config rotor. Okay. The neighbor IP remote AS is a command for the global VRF remote AS, a remote AS number, okay? And if you want to advertise, for example, network, you can use the network or redistribution command, network command or redistribution command. Assume that for the address family, okay, we can configure address family, then IPv4 unicast without VRF keyword. Here I can configure rotor config rotor AF. This is the mode of rotor config rotor. Then AF means address family. Then using the network statement, network, for example, network, and then mask. After that, subnet mask. Okay. If you want to configure BGP for VRF, the command is same with one difference. Okay. Address family IPv4 unicast for which VRF name. That's it. Okay, it's so easy. Let me to show you how we can configure the BGP between router R1 and R2. Assume that R1 is in the AS, for example, 65,000 and R2 in the AS 65,001. Let me to show you 65,000. Okay, and R2 is in a AS 65,001. That's it. Let me to configure this scenario. First, we should start with the CLI here, R1, conft rotor BGP 65,000. So easy. Then the first neighbor command is 10.1.2.2, okay, remote AS, and then remote AS, for example, 65,001. Okay. After that, address family IPv4 unicast. Please advertise the network. Because this is for global network, global virtual network, you should advertise 10.300 with the mask of 255.255.255.0. That's it. Then let's me to configure the router 2. Conf router BGP 65,001, where for example router BGP 65,001, the neighbor is 10.121 with the remote AS of the 65,000 address family IPv4 unicast. We have neighborship, and also the network 10.600 with the mask of 255.255.255.0 should be advertised. Let me check the BGP table of the router 1, or if you want you can check the routing table. Show IP route for global network. Now we didn't receive the network from router 2. After some second we will receive the network. And also let me check in R2. BGP has a slow convergence, and show IP route in the router 2. As you can see, we received this 10.300/24, this BGP route from the router 1, okay, in the global routing table. And also let me check R1 again. Yes, we have received the 10.600/24. If you want, you can check the connectivity between VPC3 and VPC6. Here in VPC3, please ping 10.6.0.10. That's it. Yes, we have connectivity. This is the normal configuration of BGP, you know it. Now we should go to the configuration of the BGP in the VRF. R1, conf router BGP 65,000, the same process, okay? Address family. First, you should configure address family, for example, IPv4 unicast for VRF A. Now, we should configure for VRF and RD. Let me talk about RD. RD is route distinguisher. RD is route distinguisher. Route distinguisher is a feature we are using it in MPLS VPN course. Okay, this is one of the advanced features of the VRF. In EVN or VRF Lite, we don't need to configure the RD, but BGP needs to configure RD. You should configure RD, for example, one value such as one quad 1, or for example 1 quad 2. It's not important the value, okay? And this is not important for this course. Only you should use it because BGP needs the RD, okay? Not for EVN. Totally, BGP needs for advertising VRF routes to configure RD. Don't think about the RD in this course because the concept of the RD is beyond the scope of this course, okay? But you should configure it. And look at here, VRF definition A, okay? I should configure, for example, RD1 column 1, and then for the VRF definition B, okay, RD, for example, 1 column 2, you should configure unique. Show VRF, look at here, I configured RD1, 1 and 1, 2. Don't think about the RD. RD is not the concept of the EVN or VRF Lite course. It's the concept of the MPLS VPN course. Very good. In R1, I configured the RD. Let me go to again to BGP, router BGP, for example, 65,000, okay? Then we are in the address family IPv4 unicast for VRFA, okay? Here, we should configure our neighbor command. The neighbor is the, for example, 10.1, okay, 2.2, again, with the remote AS of the 65,001. Neighbor 10.1.2.2, remote AS 65,001, the same IP address. And after that, we can configure the network statement. The network is 10, this is for VRFA, 10.1.0.0 with the mask of 255.255.255.0. That's it. Let me to configure R2. In R2 again, we should configure VRF definition A with the RD11 and VRF definition B with the RD of the 1.2. That's it. Then router BGP 65,001, okay? Address family IPv4 unicast. Then we should configure IP4 unicast for VRFA. Okay, the neighbor is 10.1.2.1 with the remote AS of 65,000, and the network that should be advertised is 10.4.0.0 with the mask of 255.255.255.0. As you can see, the neighbor 10.1.2.1 now is enabled. Let me to show you. In R1, show BGP IPv4 unicast summary. This is the neighborship in BGP for global VRF. And then show BGP IPv4 unicast. Okay, IPv4 show BGP for the VRFA IP VRFA, and then here you can use, for example, all, then all summary. Okay, as you can see, we have neighborship with router 10.1.2.2 in this VRF, and we receive one prefix from the router 2. These are the commands and concepts of the BGP, not of commands and concept of the EVN. Okay, don't worry about the detail, but if you want to learn more detail about the, for example, BGP, you should learn about the BGP, not EVN. Okay, let me to show you the BGP table. Show BGP IPv4, show BGP for VRFA IPv4 unicast, IPv4 all unicast. This is the BGP table. Let me to check the BGP table. We didn't receive any routes until now. Show IP route VRFA. Let me check. Show IP route VRFA. Yes, we received 10.4.0.0 in VRFA. These networks in VRFA, it's okay. And also in R2, let me check. Show IP route VRFA first. Yes, we received 10.1.0.0. Everything is okay. If you want, you can check the connectivity between VPC1 and VPC4. Ping 10.4.0.10. Okay. Yes, we have connectivity. Let me to configure the Vrf Bgp in the router 1. In the router 1, I'm using this command, Rotor Bgp 65,000, address family IPv4 unicast for Vrf. Again, the neighbor is 10.1.2.2 with the remote AS of 65,001, and then the network statement is advertising 10.2.0.0 with the mask of 255.255.255.0. That's it. Let's go to the router 2. In router 2, conft router BGP 65,001, address family IPv4 unicast, then the neighbor unicast for VRF. The neighbor statement is 10.1.2.1 with the remote AS of 65,000, and the network statement is 10.5.0.0 with the mask of 255.255.255.0. That's it. Let me to check the neighborship between these two routers. Show BGP show BGP for VRF. Okay, all summary. Yes, we have connectivity. We have neighborship with router 2, and then show IP route VRF. Look at here. We receive 10.5.0.0 from the router 2. And in router 2, show IP route VRF. In router 2, again, we receive 10.2.0.0 from the router 1. Now, if you want, you can check the connectivity between VPC2 and VPC5. Ping 10.5.0.10. Everything is okay. Let me to show you the configuration here. Rotor BGP in router R1. This is the configuration in R1. Rotor BGP 65,000. Okay, the neighbor statement in global routing table in global BGP is neighbor 10.1.2.2 with the remote AS of 65,001. Okay, and address family IPv4 unicast for global routing table. Now we should advertise the network 10.3.0.0 with the mask of 255.255.255.0. That's it. And then we should configure address family IPv4 unicast for VRFA. Okay, again, the neighbor statement. The neighbor statement is same neighbor statement because the neighbor's IP is same as the neighbor IP in the global VRF. And then we should advertise the network of the VRFA network statement. Here, the network of VRFA is 10.1.0.0. That's it. Again, we should configure for VRFB. This is the address family IP for unicast for VRFB. The neighbor is 10.1.2.2, remote AS is 65,001, and the network is 10.2.0.0 with the mask of 255.255.255.0. That's it. And if you want to configure for Rotor 2, copy the R1's configuration. R2 Rotor BGP is 65,001. The neighbor is 10.1.2.1 for all VRFs and global VRF, and also the remote AS is 65,000 again, 65,000, 65,000. The network that in global routing table should be advertised, global network is the network of 10.6.0.0, and the network of VRFA is 10.4.0.0, and the network of the VRFB is 10.5.0.0. That's it. Don't forget that you should configure RD for VRFs for advertising with BGP. Okay, and this is the configuration of the EVN routing with BGP. Until now, you learned about the configuration of the static routing BGP, RIP version 2 in static route in EVN, RIP version 2 in EVN, OSPF version 2 in EVN, EIGRP named and numbered in EVN, and finally BGP in EVN. ISIS until now doesn't support the VNET trunks configuration, and because of that, we didn't see the ISIS configuration in the routing. Now you can do routing of for example static and dynamic in the EVN environment. Totally the net result is the EVN routing is same as the VRF Lite routing, except about the ISIS. We can do ISIS routing in VRF Lite environment over the sub interfaces, but we can't do it over the, for example, VNET trunk.